Welcome to my Introduction to Networking course, typically abbreviated ITN. This will be for the CCNA version 7 curriculum. Alright, so this lab is 11.10.1. It is the designing and implementing a VLSM addressing scheme. This is going to be version 7.0. There are sadly multiple versions of this lab, so I'm doing separate videos for each one of them. So this is the version that has the police and school. So what we're going to have to do is we're going to have to work through these one at a time. I'm going to grab my pen. Alright, so how we're reading this. One thing that it doesn't point out is we need two hosts here in the middle as well. So first step that we do is we rank them. Greatest to least. 32 hosts. That one's done. 21 hosts. That one's done. 19 hosts. That one's done. 14 hosts. That one is done. Now, again, depending on how you want to look at this, I want completeness sake. So I'm going to end it with my fifth network, the one in between the police and the school. So that would be 32, 21, 19, 14, and 2. Again, I'm going to be working through the worksheet, so I'm going to be going back and forth between slides, so definitely bear with me. Alright, so this is the chart that they give us. So number of addresses required. Give me my pen back. 1, 2, 3, 4. Again, I like completeness sake. So first one is, oh, you know what? Number of addresses required, 32. 21. 19. 14. 2. I'm going to go back one slide. So, this one is PS 101. Go back. 21 hosts is PD TAC 1. Again, I don't have an easy way to uniquely identify them, so I'm just going off the switch names. PD 1. Next one is 19. That will be PS 115. Last one is, last network within that sense is PD 2. Then we have our 2, which is our interconnects. So number of addresses required. I'm going to go back one slide. So, looking at these names, hosts, I can assume from that I am talking about usable addresses. And so, that's something that changes how we tackle this. We have to accommodate for the broadcast and ID. One for the broadcast, one for the ID. That changes the way that we do this. Specifically the one for PS 101. Instead of having a different instead of having one subnet, it's going to have a different subnet because of the address spacing. And I'll explain that as we get further. 23, 21, 16, and 4. So again, I'm assuming a few pieces of information. I am assuming that information includes growth and all of their needs and all of that. So I'm doing my addressing just based off of the information that they've provided me. So now we have this guy. And this guy, we need to modify a little bit. Number of hosts, 34, 23, 21, 16, 4. You'll notice this one has the correct amount of boxes. That's why I'm like, kind of iffy with how they worded this. So we need to fill this address chart out some, and that's where we need to go through some more details. Alright, so again, we definitely need to label them. So for 34, PS101, PD1, PD2, interconnect, PS115. So the network addressing, or the CIDR component, that's where this gets a little bit more complicated. And we need to essentially answer a lot more questions before we can fill this part of the chart out. So I'm going to go forward. We're going to be filling out an address chart. And so for this, we need to figure out the subnet, or the CIDR, the grouping, the host count, which that one we already know, 34, 23, 21, 16, and 4. We need to figure out our ID, our start, our start range, our end range, our broadcasts, and I added another one for network name. Make this a little easier. So again, the one that gives us 34 hosts, that is our PS101. The one that needs 21 hosts is our PD1, PD2, PS115, and our interconnects. So we are given a little bit of information. We are given our address must start with 192.168.203.0. And we know that because that's the IP address that is in the packet tracer. Alright, so where do we start from here? Like, how do we go forward? Well, we're going to figure out the subnets for all of them first. So I'm going to go to a new slide. Alright, I'm going to grab my pen. So we've already should know basic binary, things like that. So all of these numbers are in the 4th octet. We know that because they're not above 256. So when we're building out our address chart, if we're looking at the 1st, the 2nd, the 3rd, or the 4th octet, this is typically between 0 and 255. This is between 256 and 32,000, and it goes from there. This is 64,000 to I think like 1.5 million. So depending on the hosts, that kind of dictates which ones we're dealing with. So to be a little bit more specific, working from the very far right, 4th octet, I'm going to build out an address chart. All right, how did I get these numbers? Oh, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, 2 to the seventh. So in reality, like, we look at it as doubling. We start with the number 1, then we double to 2, then we double to 4, then we double to 8, and so forth. But in reality, this is the 2 to the power of 0 spot. 2 to the power of 0 is 1. The next spot's 2 to the power of 1, which is actually equal to 2. The next spot is 2 to the power of 2, which is 4. So that's how we're getting the doubling component. All right, first address we are looking for is 34. So these are our hosts. 34, 23, 21, 16, 4. Now remember, we're in the 4th octets. So that means there are the 1st octet, 2nd octet, and 3rd octet. This is the 25th bit. This is the 26th bit. 27th, 28th, 29th, 30th, 31st, 32nd. We're in the 4th octets. So we need 34 hosts. We can do this a number of ways. I normally tell people we start from the right. In the 32th spot, the first bit on the very far right, will that provide us a host count of 34? No, it won't. It gives us a host of 1. Will the 31st spot give us a host count of 34? No, it won't. It gives us a host count of 2. That's a 0. And we follow that logic all the way down. We're in the 27th spot. That gives us a host count of 32. Will that fulfill our requirement for 34? No, it won't. We needed 32 hosts plus 1 broadcast plus 1 network ID. That's why we added the 2. That's why we got to 34. If we did not add the 2, then yes, the 27th bit would work. However, we need to accommodate 32 usable addresses plus 1 network ID plus 1 broadcast. That means we now go from the 27th bit spot to the 26th bit spot. Will the 26th bit spot give us 34 hosts? It gives us 64 hosts, so the answer is yes. Well, the nice thing is, once we have one yes, the way that the math works is, notice how it kept doubling? That meant all of the other spots to the left will be larger. And so we add them there. So that would be the 3rd octet, 2nd octet, 1, 2, 3, 4, 5, 6, 7, and the 1st octets. So 8 bits from the 1st octet, 8 bits from the 2nd octet, 8 bits from the 3rd octet. That's 24, 25, 26. That means /26 will give us the appropriate space that we need. And what is our increase size? Because we're in the 4th octet, we're going to be able to use the same chart for our increase size. So we're increasing it by 64. This is sometimes called a grouping or a block size. Alright, so I'm going to erase this problem. And we're going to do the same steps for all of them. So 23. Does the 32 spot give us 23 hosts? No. Does the 21st spot give us 23 hosts? No. Does the 30th spot give us 23 hosts? No. Again, this is going to be the host count. And because we're in the 4th octet, our grouping as well. 29th spot gives us 8 hosts. Nope. 28th spot gives us 16 hosts. Close, but nope. The 27th spot gives us 32 hosts. We need 23. It's larger than 16, but smaller than 32, so yes. Everything past that will be larger. It is in the 27th spot. And our grouping is 32. 21 is going to be the exact same thing. So I'm going to clear this. For 16, same process. 32 spot gives us 1 host. 31st spot gives us 2 hosts. 30th spot gives us 4 hosts. 29th spot gives us 8. 28th spot gives us 16. We need 16, so yes. That's a /28. And our grouping will be 16. Alright, last one will be a host count of 4. 32 spot gives us 1 host. We need 4. 31 spot gives us 2 hosts. We need 4. 30th spot gives us 4 hosts. That's what we need. Everything to the left will be 1s. /30. Host count 4. So, let's go back and let's build out that information in our address charts. Alright, went back a few slides. Subnet or CIDR, we're just pulling it from the math we just did. Group was 64. /27. 32. /27. 32. 16 is a /28. 16. /4 is a /30. Grouping of 4. So what does this mean? Well, once we know the subnet or CIDR, we know which octet we're working with. We are working with the 4th octet. /26, /27, /28, /30, all of them are in the 4th octet. We're going to be adding the group to the 4th octet. Zero plus 64 is 64. Alright, first network ID, done. Second network ID, we're adding 32, that's the group. We're adding that to the 4th octet. /64 plus 32 is 96. Second network, done. Third network, we're adding 32 again. Again, we're adding it to the 4th octet because /27 is in the 4th octets. /32 plus 96 is 128. That means third network now done. Done. So we're going to go to the 4th network. We're adding 16 to the 4th octets. 192.168.203. 128 plus 16. 4, 3, 1. Double check my math. $144. My math was wrong. 8 plus 6, that is 14. Got to carry the 1. That's 44. So, yep, 144. Fourth network, done. Last network, we're adding 4 to the fourth octet. (203). 144 plus 4 is 148. We started with this address, so we're going to leave the growth network something to start with. So we have our 5 networks. So how I normally do it is I do the start and end points, and that's how I figure out my broadcasts. Broadcasts is going to be 1 less than the next network ID. Now if we're dealing with the third octet, that gets a little bit crazier, and I've done separate videos on that. So what is 1 less than the next ID? The next ID is 64. I'm going to drop the 192.168.203. They're still there, I'm just not going to keep writing them out. So again, this one we'll look at the next ID and subtract 1 bits. .95, 127, 143, 147. So now we have our start and our end. Now we can go what's in the middle. So again, we're building out a number line, so we don't need any overlapping. 2, 64, 96, 128, 144, 148. You'll notice this one is growth. We're not going to touch this one anymore. We only really needed the 5 networks. So this is just left for growth. Mean future network. So we're not going to touch that anymore. We're only dealing with the 5 networks we needed. Alright, so what is between 0 and 63? Again, we want to build out a number line. So we're going to be 1 greater than the ID. Again, the 192.168.203 is still there. I'm just not writing it because it will get really messy if I do. What is 1 less than the broadcast? That will be the end range. These are all through. So the way that we read this is for network 1, for PS 101. The ID is 192.168.203.0. The starting range is 192.168.203.1 through 192.168.203.62. These are ranges, so .1, .2, .3, .4, .5, and so forth. The ending, or the broadcast, for the first network ID is 192.168.203.63. So now we've completed our address charts. So now we need to answer some questions. I would suggest screenshot or write this out, have it on a separate piece of paper, because we're going to have to fill out some charting information. Alright, so we know that we have device for police. We have a router for the school. We have 4 separate networks. PS 101, PD 1, PS 115, PD 2. And now I'm going to follow the same address logic. So this will be PS 101 87, PD 1 11. So I'm grabbing this from the network chart, and I'm trying to be consistent as possible with the way that we did our addressing. 23. Alright, so I'm going to go to the next slide so we can figure out how we're going to do this. Assign the first usable, likes to keep changing my pen, first usable address for the police for the two lands and the WAN link. So, looking at that, first usable in the WAN link, that will be PD1, PD2, the interconnect. Alright, interconnect 192.168.203. First usable is 145. PD2, first usable is 129. PD1, first usable is 65. I'm going to write out the addresses. And technically, I'm going to try to make this as easy as possible. But we also need to include their subnet, so, or their CIDR. One is 30. One is 28. 20. Oh, that's 27. What we're doing is we're reading it off our chart. First usable, the start range. Interconnect, PD1, PD2. That's why I took the time to label everything. Alright. Assign the first Come on, PowerPoint, stop doing this. First usable address to the appropriate subnet for the school. But again, we know that our interconnect is going to be slightly different because we've already used the first address, so we can't do that. So that will be PS 101, PS 115, interconnect. Again, I'm going to stop writing the 192.168.200 or 203. That address portion is not going to change, so I don't want to get it all kind of confuffled by continuously putting that there. Last usable for the interconnect is 146/30 with 115. Again, first usable will be a .97/27, and with 101 that will be .1/26. Alright, so now assign the second usable address to the switches. Alright, so PS 101, PS 115, PD, PD 2, 1. Second usable. Alright, that means first one, PS 101, second usable is .2/26. With 115, that would be .98/27. PD1 would be a .66/27. PD2 would be a 130/28. Reachable from all hosts Well, we should be able to do that. That's on an addressing portion. All right, last usable address to each of the hosts. All right, so I'm going to write this PS 101.87, PS 115.12, PD1, PD2, PD1 is 11, PD2 is 23. All right, last usable 6.62 with a /26 with 115. That would be 126/27. Last usable for PD1 is .94/27. PD2 last usable is 142/28. So we're still just working on getting information to build the address chart. We're not at the configuration portion just yet. So let's go back and let's fill out our address chart. All right. Grab my pen again. So some of this, like the interfaces, we're going to have to look at the packet tracer for us to figure out. But for now, I can at least pull some basic information. So, going off the question, assign the first usable address to the police station for PD1 and PD2 and the interconnect. The interconnect is on the serial interface. 192.168.203.145/30. I will write the subnet masks, not insider notation, in a little bit. 192.168.203.146/30. I'm going to try to do as much of this as possible, and then I'll go to the address chart, or then I'll go to the packet tracer to figure out interfaces and whatnot. All right, PS 101. These are going to be going to the switches. This is going to be the .2. Because this is assign the second usable address to the appropriate subnet to the switches. These are the switches. Alright, so .2, that'd be a /26. So the next one would be 115. 115 was .98, and that was a /27. Next one would be PD1, which is .66 with a /27. Last one would be 130 with a /128. I'm going to finish filling out the address chart. Alright, and I'm going to double check just to make sure that all looks correct. Alright. Default gateway. That's going to be the router's IP. Alright, for PS1, the router's address is going to be 192.168.203.1. Remember, Assign the first usable address to the appropriate subnet to the police and to the school. These are the interconnects. So that would be the WAN link. So they don't need a default gateway because they're a direct point-to-point. The rest of these do. Alright, so that was .1. Next one is .97. PD1 is .65. Oh, the way I did this, that's right. 97. For PD is 65. For PD2 is 129. Alright, finish filling out the address chart. And the fun part is, then now we have our PCs, which are going to use the same starting address. Sorry, I was going to use starting addresses in the network ID specifically is not going to be changing. So that's going to all be 192.168.203 because the subnet is making those all stay the same. So I want to just finish writing this out. That way I can focus on the parts that are going to change. Alright, for PS101, this is the starting address, but this is all part of PS101. That means the gateway will be 1. The last usable will be 62. Again, we're building this off of our address chart. That's how we did this. This will be a /26. For PD1, PD1 is .94. And that will be a default gateway of 65/27. PS115, PC12 will be 126 with a subnet of /27. PD2 computer 23, 142 with a subnet of /28. The default gateway, again, for PS115 is 97. Default gateway for PD2 is 129. Alright, so we need to finish filling out these pieces of information. I don't have those pieces of information just yet. We have to look at the packet tracer. Alright, so how do we figure that part out? We need to go back to the original file, and we need to mouse over the cable. So for PD2, it's gig01. For PD1, it's gig00. This side is gig01, this one is gig02. So let's double check school. So again, the switch side is gig01, the router side is gig00. We can't do that, so what about, can we change? There we go. So I know it says gig01, that's the switch interface. If we zoom in a little bit, we can see that this connection is gig00. So now that we have that information, we can finish building out the address charts. Alright, so that means this is for PD1. 1, this is for PD2, this is for PS101, this is for PS115. Alright, so that meant for PS101, the router's IP address. Let's try that again. Router's IP address is 192.168.203.1. For PS115, 192.168.203. Address 97. That will be a /27. That will be a /26. Alright, for the police PD1, that'll be a .65 /27. For PD2, it'll be a 129/28. So basically what I did is I looked at the default gateway, that's really the router addresses, and I looked at what switch they were attached to. That way I could map which interface goes to which device. I was able to do that because we built out the address chart. So now we have a few more things we have to do. The subnet masks, we're not going to be allowed to keep this as CIDR. So we need to convert /26, /27, /28, and /30 to dotted decimal form. So again, in the 4th octet, we're dealing with 2, 3, 4. 1, 2, 3. That type of binary. So /30. If we take 11111100 and we convert that to dotted decimal, that'll be 252. I'm not going through the math. You guys should already know how to do the binary conversions. So that means these two will be 255, 255, 255.252. Again, we're working in the 4th octet. Alright, that took care of the /30. /28, 1111000. 128 plus 64 plus 32 plus 16. Alright, I lied. We'll do the math. So 12, 14, 20, carry the 2, 2, 4, 10, 13, 14. That'll be 240. So that means the /28s are .240. Again, 4th octet is where we're working. So these are the /28s. .255, 255, 255.240. Alright, that's the 240. Alright, that took care of that. /27. 1110000. 128 plus 64 plus 32. 8 plus 4 is 12. Plus 4 is 4. Carry the 1. 1, 3, 9, 12. /27s are 224. 255, 255, 255, 224. Lots and lots of writing. 224, 255, 255, 255, 224, 255, 255, 255.224. All right, let's erase this. Last one is /26. 11000000. 128 plus 64, 192. Again, that's in the 4th octet. All right, address chart now complete. Ooh, that hurt my hand. So, we are not done. We've just done the start portion of this. Now, what we need to do is configure the information. All right, this is one of the older ones. Again, this is from lab. I can't even see the lab name. Give me 1 second. Lab 11.10.1, designing and implementing a VLSM addressing scheme. This is from the version curriculum version 7.0. And this is not the correct one, because this one has east and west, not the police, so give me 1 second. All right, so that is the correct one. No, that is not. All right, so this is one of those fun labs. So you'll notice I closed the lab, reopened it, made sure it was the correct layout with the correct addressing, and I'll explain that a little bit later. So now we need to work through the lab. So again, we've already filled out the addressing chart that was required. We've done the design. Now we're dealing with the configuration portion. So first thing I'm going to do is I'm going to adjust my preferences so that my font is large. So I'm going to start off with my police router. And again, here's the addressing that we've done. It's just sitting off the side of my screen. And that's what I'm going to be working on. So, get to my global configuration. So, enable conf t interface gig 0/0 IP address 192.168.203.65 255 255 255 224. No shut. Int gig 0/1 IP address 192.168.203.129 255 255 255 240. Oh, IP address. No shuts. Int serial 0/0/0 IP add 192.168.2 203.145, 252, that's the /30. No shuts. Router 1 done. You notice I keep typing the same stuff over and over and over again. So I'm going to modify this a little bit by going to a notepad. Okay, so enable conf t interface gig 0/0 interface gig 0/1 interface 00/0/0 IP address. So I'm going to be doing this for the school router 192.168.203.146. No shuts. I'm going to be doing the no shut on all of them. All of them are going to start with the same addressing. Alright, so I'm configuring school gig 000, gig 00 for PS101, which would be 1, subnet mask 192. For gig 01, that'd be a 97 to 224. Again, building it off my address chart. All right. Next, I'm going to be doing the VLANs. So, enable conf t interface VLAN 1 IP address. First one is 192.168.168.203. Dots. This one will be dot 2. Which would be a 192. Alright, pound. This is going to go for PS 101. VLAN, alright, all that looks good. No shutdown. I'm doing this on multiple devices. So I want to be able to keep records of what the heck I'm doing. PD Act 2. Alright, so we already know that for PS115, the IP address is the second usable, so .98, subnet mask 255.255.255.224. For PD1, second usable is .66, and that's also a 224 subnet. 192.224.224. All right, PD2 is going to be a 240 subnet, and its IP address will be 130. So again, PS101, that's the IP address. PD1, that's the IP address, that's the subnets. PS115, that's the address. PD2, that's the IP address. So let's double check. PD2 is 130. 255.255.255.240, yes it is. PS115, 192.168.203.98. subnet 255.255.255.254. That is correct. PD 192.168.203.66, subnet 255.255.255.224. That's what I got. All right, all that lines up. So again, on PS 101 switch, on PS 115, on PD1, on PD2, all right. Was I? Okay. I'm not sure if I was seeing that correct, but alright, my results are not increasing. Curious why. Alright, so I'm going to keep going forward. I understand the completion rate is not going to increase. I did find a logic flaw in this packet tracer, which I'm going to finish the packet tracer correctly, and then we will break down the logic flaw. So we've done the VLANs, we've done the addressing. All right, so for PD 1.1. Okay, that was just weird. All right, PD 1.1. Not sure why it already had a IP address in there, 192.168.203. I'm going to copy this because I'm going to keep pasting this over and over again. So for PD1, TAC 11.94, it's a 224 subnets, and this is going to .65. PD2. This is a 142 subnet 240.203.129 as the appropriate gateway. All right, on this guy, PS 101. PS 101 87 is 62. Subnet is 192. Default gateway is .1. Last one, PS 115. Which is 126. Subnets 224. Default gateway 97. So, you will notice, first of all, the completion rate did not increase. All the devices now have addressing, and to confirm all of that, I was going to ping, but the way this was designed, it actually was a little bit misleading. Follow the guidelines provided in the curriculum regarding the order of these subnets. The subnet should be contiguous. There should be no unused addresses between subnets. Provide the most efficient subnet possible for the point-to-point link. That's where this gets a little bit more complex. Alright, so when I was talking about the logic flaw, you'll notice if we check the results that our IPs and subnet masks are incorrect. Well, what makes this interesting is our serial interfaces. These guys, the last network, is correct. That means the only way for the serial to provide a correct response is if this addressing chart was correct, but the way that we laid out our networks are not how the packet tracer wanted us to do it. And so, did a little bit of research, and this is the answer key. And one of the things to note is this guy. We ranked them greatest to leasts per the curriculum. The curriculum always says the number of hosts. When we do this, we rank them. This one did not rank them. So it flopped these two. And so that made this a little more complicated. Not just that, you'll also notice the way that the host addresses are and the way that the answer key is, they are not actually the same. So I'm actually going to change this up a little bit. So, PS101 had 32 hosts. But according to the address chart for this packet tracer, that is not correct. For PD2, again, the LAN for the PD2 network, they had them flopped. So there really is no way to get this. There is no way to get full credit on this assignment unless you already had the addressing scheme present, because the answer key and the way that this was portrayed are different. And I will be doing separate videos for each of the scenarios as laid out by the answer key. I don't have any other way of saying that, because when we look at the packet tracer, and we look at the answer key, they do not line up. So that means our answers won't line up. So the completion rate can never actually increase unless we had access to that answer key. So again, I will do separate videos for each of the scenarios per the answer key. This is how you would actually do this lab for it to actually function. And I'll just do separate videos for each of them. Questions, thoughts, concerns, let me know. Alright, just to reiterate the screwiness of this. For the network for PS101, I understand that it doesn't show the correct addresses. It wants me to modify the machine so that PS101 is 94 with a 224 subnet and a 65. They flipped the two networks, PS101 and PS115. So again, unless you have the answer key, there is no way to complete this lab. The logic and the structure of this lab is not valid. So I had a question, and it took a little while to figure out an appropriate answer. This is the lab that I provided a correct walkthrough on how to do the proper subnetting, even though my score never actually increased. And again, I wanted to point out why that is. This is actually an invalid lab. There is no way to correctly do this lab. And I posted separate videos on how to identify valid and invalid versions of this lab. This lab is expecting these details. And 21. If they're looking for this network right here to have a specific IP address that's only able to be obtained if this is the way the diagram is. So again, I did a separate video, what's valid, what's invalid. You may have to cycle your packet tracer a few times, because I have found that half of the packet tracers, when it comes to lab 11.10.1, as you open them, it actually flips these numbers, and it doesn't actually fix the grading sheet. So they don't allow you to complete it with a 100% completion rate. So again, check out the video where I showed what's valid, what's invalid. Questions, let me know. Thank you. If you have any questions or anything, please feel free to reach out. Again, with this material, being able to ask questions and discuss some of the topics in the lecture help build long-term retention, so do not be afraid to communicate with this topic. Again, I'm here if you need anything. Thank you.